So there are three forms that we can have for our quadratic equations: that we can have for our quadratic equations: standard, vertex, and factored. And each of them have their benefits and their tricks to them. And what we're really going to focus on is in terms of the features that we're looking for. Let's talk about finding the vertex, the y-intercept, and the x-intercepts. What we'll do is we'll see in which forms these are easy to find and what we need to do to find them when it's a little more complicated. So let's talk about standard form first. So this is what we've been looking at so far, the y equals ax squared plus bx plus c. Now the thing that we could immediately read from our standard form is our y-intercept. That would be the first piece that we could find without much calculation because it always ends up being equal to c. So you can immediately get our y-intercept at 0, c. So for our example that's up above here, the negative x squared plus 10x minus 16, we know we'd have the coordinate 0, negative 16. From there, we have a bit of work to do. So to find the vertex, that could be our next step. What we do is use that formula we talked about in the last video where we have x equals negative b over 2a. And then to find the y-coordinate, you plug in x. So you plug in that value for x that you found. So for our case, we would have x equals negative 10 over 2 times negative 1. So we have an x-coordinate of positive 5. And then for y, we would go negative 5 squared plus 10 times 5 minus 16, all to simplify to a positive 9. And what we end up with is an xy coordinate. So we'd have 5, positive 9. The next piece that takes a bit of work is the x-intercepts. I feel like I'm kind of organizing this in terms of difficulty, although that just kind of depends on the scenario. But with the x-intercepts, what we're doing is we're solving 0 equals ax squared plus bx plus c. So this takes us back to our videos on solving quadratic equations, whether it's factoring, square root method, completing the square, or quadratic formula. So we could use any of those four methods in order to do this. So in the case of our example here, I would have 0 equals negative x squared plus 10x minus 16. I'm going to go ahead and divide by negative 1, so I have positive x squared. And all the signs change. So 0 equals, let's see, multiplying to 16, adding up to a negative 10. I'm thinking negative 2 and negative 8. So x minus 2 equals 0, so x equals 2. X minus 8 equals 0, so x equals 8. Not too bad. Okay, so with standard form, y-intercept will be clear just from the initial format, but we can find the vertex and x-intercepts with some calculations. Let's talk about vertex form. So vertex form is this y equals, and we could have our value of a outside, x minus h squared plus k. And what's going to be easiest to find first here is the vertex, hence the name vertex form. So the vertex is going to have an x-coordinate that's equal to h and a y-coordinate that's equal to k. And something you want to be very careful of here is that in the format, we expect to have subtraction there. So if we have subtraction, our h-coordinate's positive. If we have addition, the h-coordinate's negative. So it kind of appears opposite of how it shows up in the original format to how we write it in the vertex. Now the value for k for the y-coordinate matches exactly. If we have plus k, it's a positive value, minus k, negative value. So for our scenario here where I'm seeing x minus 5, that tells me I have a positive 5 for the x-coordinate and then a positive 9 for the y-coordinate. And that's it for the vertex. So no calculation, it's just grabbing it from the format. Next up, we could do the y-intercept. And with that, we just plug in x equals 0. So I would go y equals negative 0 minus 5 squared plus 9. So that's a negative 25 plus 9, so negative 16. So that gives me a coordinate 0, negative 16. Next up, we will have our x-intercepts. And what we're going to do is solve 0 equals a times x minus h squared plus k. And we can do this using the square root method. So let's see how this comes out. If I have 0 equals negative x minus 5 squared plus 9, and then I could go ahead and subtract 9 from both sides. So what I'm working on is isolating that x minus 5 squared piece. I want to get this all alone on one side of the equation. So I have that negative 1, so I'm going to divide away a negative 1, so 9 equals, and then I have this positive x minus 5 squared. And now I can go ahead and take the square root of both sides. So we have a plus or minus 3 equals x minus 5, add 5 to both sides, so 5 plus or minus 3, so we get x equals 8, or x equals 2. So no factoring involved there. When you solve for the x-intercepts with the vertex form, you can use the square root method. Okay, one more case here is the factored form. And this can be a little tricky to write out a general format because there's a lot of ways this can show up. What it's making obvious to us, though, is our x-intercepts. So we're going to start with our x-intercepts here, which would be to solve 0 equals and then our factored form, which, if it's already factored, we can just jump to our product of zeros rule. So for this case, we'd have 0 equals negative x minus 2 times x minus 8, which means x minus 2 equals 0, or x minus 8 equals 0. So we get x equals 2, x equals 8. And there's our our horizontal intercepts, or our zeros, or also called our x-intercepts. Lots of names for our x-intercepts. And then from there, we could go to our y-intercept. Y-intercept's never too bad because it's just plugging in x equals 0. So we're going to plug in x equals 0. So we'll have y equals negative 0 minus 2 times 0 minus 8. So y equals negative 16. And that'll give us the coordinate 0, negative 16. All right, our last one here is the vertex. And there's a few ways to go about this. Something we could do is expand the factored form. So what we could do is go from factored form to standard form and just use the rules we used there. So using the x equals negative b over 2a, that works. Something you could also think is the x value is halfway between our x-intercepts. So what I mean by that is we have x-intercepts at 2 and 8. Let me use green for our example here. So 2, 3, 4, 5, 6, 7, 8. So if we're crossing the x-axis at those spots, halfway in between is going to be the x-coordinate of our vertex because of that axis of symmetry. So with that, we could kind of jump ahead just kind of using geometry and symmetry, that the x-coordinate would be 5, and then I could get the y-coordinate by plugging in 5. So negative 5 minus 2 times 5 minus 8. So y equals a negative 3 times negative 3, so a negative 9. And there we'd have it. But if that's uncomfortable, you can also do that just expanding out by foiling and getting into the standard form, which would look just like this. And then we could plug in to our vertex formula. Okay, so with that, let's get some more practice with this vertex form, because that's probably the newer form that you may have not seen before. Standard form we've had some practice with, and even factored form with our practice with factoring. So let's take a look at our vertex form. So if I want to determine the vertex of each of these equations, so I'm looking at that as h, and this is 10. And what I'm going to have is for my x-coordinate, so I see x minus 6, so that's going to be a positive 6. And then where I see minus 10, that's going to be a y-coordinate of negative 10. Again, it kind of looks like changes sign, keep sign. With this one, I see a plus 5 and a plus 1. So my x-coordinate, because I see plus 5, the x-coordinate is going to be negative 5, so it switches. And then plus 1, plus 1. So again, y stays the same. And why this is we could rewrite this as y equals 2/3 x minus a negative 5 squared plus 1. And that way you could see that negative 5 exactly, because we expect to have subtraction in there with our vertex form. So if you wanted to see it with the subtraction, we'd have to have a negative 5 in order to make it a plus 5 there. Okay, write a quadratic equation with the given value of a and the given vertex. So writing the quadratic equation, which we're following that format, a times x minus h squared plus k. So a is going to go out front, so we'll have a 2. X minus h, so we have a negative 4, so minus negative 4 will be a plus 4. And then positive 7, so a plus 7 on the outside. With this one, we have y equals, and we'll have a negative 4 multiplying outside. X minus a positive 3, square that, and then a minus 5 on the outside. That's how we can work with our quadratic equations in vertex form to find the vertex and also see this number outside multiplying.